Hello guys, welcome to a new beginner series of ESP32, and in this series I will be covering ESP32 board in detail, and I will also show you the projects using this ESP32 module. And this is going to be the first video in which I will discuss some of the basic details of this board and the pinouts of this ESP32. So let's get started. So what is ESP32? So basically this board is a microcontroller which was developed by ESP32 Systems, and it is like other microcontrollers like this Arduino Uno, but besides just having this analog and the digital pins, this board has numerous features like this comes with built-in Bluetooth and Wi-Fi. So if you see on the top of this microcontroller, this black colored strip is an antenna, right? So through this antenna it can connect to other servers and networks, and it can also create its own networks and servers so that other devices can also connect with it. So if I show you the model number of this ESP32, this has model ESP32 DevKit V1, right? This is a main model number, DevKit V1. So this ESP32 has a dual core microcontroller. Dual core means it has two cores, core 0 and core 1. So core 0 handles the Wi-Fi and the Bluetooth functions, and core 1 handles the peripherals like sensor and actuators, right? And this dual core microcontroller runs at 240 megahertz, which is very high as compared to Arduino Uno. So Arduino Uno runs at only 16 megahertz, which is very low as compared to ESP32, right? And one interesting thing is to note that the main microcontroller chip on the Arduino Uno is this one, which is clearly visible. But in the case of ESP32, it is packed inside this metal case or metal shell, right? So if you remove out this metal shell, you would see something like this, right? So why do we use this metal shell over the main microcontroller chip? Because this ESP32 comes with built-in Bluetooth and Wi-Fi, right? So to protect this chip from the electromagnetic interference from the surrounding signals, we use the metal case over the chip of the ESP32. Now let's discuss the pinout of this ESP32. And in this image, as you can see, it has total of 36 GPIO pins. And these number of pins can vary depending upon what model you are using, right? So GPIO stands for General Purpose Input Output, okay? And unlike Arduino, which has dedicated digital and the analog pins, the ESP32 does not have these kind of pin. It has only GPIO. So you have to configure these pins as analog or digital pins according to your requirements. And in my case, I have 4 power pins, 2 ground here, this one and this one, and this is a 3.3 volt input, and this is a V in, right? And this ESP32 operates on 3.3 volt. So if you input 5 volt on the V in, this voltage regulator converts that 5 volt into 3.3 volt. Now in addition to 4 power pins, we also have 25 pins which can output PWM signal with 16 bits of resolution. So 16-bit resolution means we can use values from 0 to 65,535 in analog write function. And we also have 16 pins which can read analog signal with 12-bit ADC. ADC means analog to digital converter. And this means that we can use values 0 to 4095 in analog read function, right? And we also have two 8-bit DACs. DACs means digital to analog converters, right? And lastly, we also have pins for capacitive touch sensing. So this is also one of the advantages of using ESP32. And this boot button is connected to GPIO 0, right? And when we press this button, it is pulled to low. That means it reads 0, right? And when we upload the program in our ESP32, we need to keep on pressing this button until the code uploads in the ESP32. And in my next video, I will discuss how we can use this boot button to upload the program in the ESP32. So I hope you have understood the basics and the pinouts of this ESP32, and this ESP32 series is going to be very interesting. So make sure you subscribe to my channel for learning amazing electronics project. And if you have any doubts regarding what you have learned so far, let me know in the comment section. And thanks for watching this video.